Welcome back, everyone, to another presentation up to the time. Today, we're going to be looking at superior trochoids. But first, before we start, let us define what a trochoid is in technical drawing. A trochoid is a curve traced out by a point fixed to a circle where the point may be on, inside, or outside the circle as it rolls along a straight line. What is a superior trochoid? A superior trochoid is the path or locus of a point which lies on the outside of a circle when it rotates along a straight line without slipping. So, we have just defined what a trochoid is and what a superior trochoid is. This is the example that we are going to be creating today. The superior trochoid here. This is the problem, and these are the steps. I've also added some visual steps to help those as I explain this process. So the first thing is what the problem states. Let me just zoom in over here. Problem. Draw a locus of a point 7 millimeters away from the periphery of a circle which rolls on a straight line path. Take the circle diameter as 56 millimeters. Place a tangent onto the curve at a random point M. So the first thing is, I have all the steps laid out here. The first thing is to take the circle and divide it into 12 equal parts, which is done down here. This is step one. So let me take out my annotation. Yeah. And that is what we did down here. Take the circle and we divide it into these 12 equal parts here. So that is step one. Step one here. Then step two, we find the circumference of the circle. To do that, we need to multiply the diameter by pi. So the diameter is given, which is 56, and pi is 3.142. When you multiply these numbers, you get 176 millimeters. And that goes here from this point all the way to this point. That's called the circumference there of the circle. That will give us one revolution from here all the way over to here within one revolution of this circle turning. Okay. So after we have done that, what's the next step now? Is to divide the circumference line into 12 equal parts. And this line here, which is the circumference, this should be divided into 12 parts there, as you can see. That's the next step. That's step 3. And we also need to divide the rolling circle into 12 parts, which we have done that, and then we draw horizontal lines from the divisions on the circle, which are these here. These divisions, we draw the horizontal line. Right, so after we have all our horizontal and vertical lines inserted, then we go on to the final step, which is to roll the circle. Take the rolling circle, OC, and move it along. So take the rolling circle, OC, and move it down each point and make a mark. I think that the rolling circle in this case isn't OC, it will be OP, because we can be rolling this outer circle. This is the outer circle that actually moves. So that should be OP. So take the rolling circle OP and move it down each point and make a mark. Each time the circle moves down the line, which means each time the circle does this, moving down the line, like that. That's the path of the circle. to go to each one of these points here until it gets to 12. Each time that happens, it also moves up a line. So you start off here at P, then we move up this line, then we move up that line, then we move up to this line, then we move up, the point moves up until we get to the top here, and then we come back down. We come back down till we hit the baseline where we started. Okay, so that is the strategy as to how we are actually going to be creating this superior trochoid curve. I think I've gone through enough of the strategy, plus the strategy is all laid out here for you. We have some visual steps. So I'm going to take this time now to produce this superior trochoid S-star. So the first thing is, let's create the outer circle. And we have here the outer circle is radius 35. So we're going to see the circle. We're going to start here. And open that is radius 35. That's my circle. The inner circle is radius 28. See for circle again. 28 is our radius there. And our circumference is 176. So I'm just going to put that in 176 starting from here. 176. That's it there. I just like to do this by creating the center so that all of my shapes have a center. So I'm just creating a center layer. Place these into the center so that we know that's the center there of our circle. Let's go now. Now, div to divide these circles. Actually, I'm only dividing the outer circle. Div, that's the outer circle, type right. So why can't I see my divisions? I need to turn on my point expression. So I type DDP. I'm going to turn those expressions on to point size 2 and set in absolute units. Okay. So my points are there. I'm going to number them at this stage. It's 12. 1, 2, 3, 7, 8, 10, 11, back to 12. Everything is labeled. Now I'm going to divide this line. Div, the command, select the line, 1, 2, enter. 12 divisions there. And from these 12 divisions, I'm going to project lines up. So enter the first line, and I'm going to copy. And I'm going to also array. So select the base point. Now I'm going to come down here, the array, and then enter the number of items you want to copy. Let's say 11. Okay, well. Those are the divisions there. And then we also need these lines now, the horizontal lines from the divisions on the circle. Very important. We're going to insert these now. Insert one line and then copy the rest. So 12 is a single, 11 goes through 1, 10 goes through 2. 9 goes through 3, but that line is already in as the center line. 8 goes through 4. 7 goes through 5. And 6 is a single backside. Well, I'm going to take the stairs to clean it before I know it. So the drawing is all cleaned up. We have our circle divided, which is the rolling circle. And we have our baseline divided. Now, what we need to do is I'm going to be labeling the divisions here. So start off. So this is where the circle is. Point is 0. And move over here to point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then we end off at 12. So that's the line label. Now, what are we going to do? We are actually going to plot this rolling circle. But this point down here is point, let's call that P. And let's call it in here C. So we are going to be plotting the circle OP. I'm going to put the first point on my outline layer, and I'm going to go on outline layer as I insert the other points. So we move from 0 to 1. And that means we move up the line. This would be our new point. So now we move from 1 to 2. And we go up the line again. So we are looking for a point here on 8 and 4 line. And we move from 2 to 3. So we're looking for a point on the 9 and 3 line, which is right here. We move from 3 now to 4. That means we're looking for a point on the 10 and 2 line. We move from 4 to 5. So we're looking for a point on the 11 and 1 line. Then when we move from 5, we move to 6, which is midpoint. And we find the point here. This point, and now once we are at 6, we can mirror the other 6 points because this shape is symmetrical. Sorry, the curve that is going to be produced is symmetrical right here. So this is the example. So imagine I draw a line right here. That means that my curve is symmetrical. You can see this is the line of symmetry that actually goes through my whole curve right here at this point. So once we reach point 6 over here, we can then mirror the other 6 points in so that we can get all 12 points and we can create the SPL, the spleen. All right, so what I'm going to do, I have a nice trick. I normally turn off my construction layers and I then mirror everything. These points come by here and I do this in a mirror. It asks me if I want to erase the source objects. I say no, because I want to keep my source objects. So I've selected the points, the first 6, and I've mirrored them. Now I'm going to SPL and spleen the create this spline, sorry, to create this polygon curve. And this curve that I'm creating is the superior trochoid curve. That's what a superior trochoid would look like. Now I'm going to turn on the construction layer so that we can have a look. So I'm going to leave the circle there, but I'm also going to take it back right here. Now I'm going to place things into my outline layer. This is the circle that rolls. This goes in outline layer. Whatever. I think I should put the baseline in outline layer too. Yeah. So that is my superior trochoid all done. Now, what I'm going to do, I'm going to place some labels onto here, and then I'm going to create a tangent at a random point M. Let me just transfer all of my points into my text here. Now, I placed the tangent in this side before, so I'm going to place it on the left side. So let me choose a random point right here. And I'm going to put the tangent into the green layer so that it stands out. Then I'm going to place M here. So the whole purpose of this is to actually prove that point N is in tangent with this whole curve. How do we do that? This is the rolling curve. We're going to take the rolling curve now. And we're going to move the rolling curve from there. And we're going to place the axis of the rolling curve at point M. So the axis of the rolling curve is at point M. And what happens now is it makes the cut at the midline at 2 points. A point here between 3, 4, and a point here just after point 5, right here. We're only interested in one cut. I'm interested in this cut here. So we're the center line interacts with the circle and the cut right here. So I'm going to place a point here. That's the cut that I'm interested in. So I can remove the circle one. I'll also put this point in dimension layer green so that we would see this. So that's the cut there that it makes. Then we take a line and we project this down perpendicular to the base. And from that point, we connect that to M. Now that there is our normal. This is our normal line that we have just established. I'm creating a back line so that I can extend the normal line. Right. So that it's obvious. Put this in the construction here. Now, once we have discovered our normal, so just to create the tangent is fairly easy. We just need to create a perpendicular from the normal line. So let me do that now. For that, I'm going to create a semicircle on the line, and then I'm going to trim it. Because we know, we create a circle, which is 360 degrees, and I'm going to remove half of the circle, so that means I've removed 180 degrees. And now I'm going to find 90 degrees by dividing this circle in half. So coming onto this 180 degree line, I'm looking for the midpoint and bringing it back to the axis. That there is my 90 degree interaction, which is also the perpendicular, which also is my tangent. So now I need to extend this now. Extend. See it. So this needs a back line. I'm just going to create a back line here and extend to that back line. The way that didn't work, so I'll fill it. This is a form of a construction I'm just going to leave this here and bring this to the center of M. So remove that and then just put in the angle. That's a cleaner setup. So that there is our tangent and our normal inserted. Now I need to label. So I'm just aligning the text to the line at this stage. So I've inserted the word tangent. Now I'm going to insert the word normal. Oh yeah, I like this about AutoCAD. You can write in lowercase, and then there's an option here to just transform lowercase to uppercase. Really like that feature. It saves me a lot of time, right? And I put that in there. I would always encourage people to save regularly. So I'll just save my work there. Now I'm going to rotate this text. RO to rotate the text. Select the text. RO is to rotate. Select. And then just put it like that. So that's good enough for me. So I got my normal and my tangent in. And my circle has been ruled 1 revolution. Okay, so before we close off this video, I'm just going to now dimension my circle. So this is radius 28. And this one is radius 30, 35. And what's the distance of the circumference? Let me put that in. It's from here to there, and that is 176. Now, let me label this, and then I'm finished. This is called a superior trochoid. Superior trochoid, all done. So let's review, and then we can close this video. So what did we do today? We did a superior trochoid, and I solved the problem. The problem was to draw a locus of a point 7 millimeters away from the periphery, sorry. I'm just getting my annotation. So let me reread the problem again. Draw a locus of a point 7 millimeters away from the periphery of a circle, which rolls on a straight line path. Okay. Take the circle diameter as 56 millimeters. Place a tangent onto the curve at a random point M. So we took the circle diameter, 56. That is 56 diameter, which is also 20 radius. And we offset it 7 millimeters away from this circle 28 radius, and we got the 35 radius circle. And the 35 radius circle is what we ruled. Okay, so it is correct. So that has been done. What else has been done? We have placed a tangent onto that right here at some point M. And we have also rolled the circle to create the superior trochoid. So there's nothing more to do in this drawing. I hope everyone has understood this drawing. I will be placing in the Google Classrooms the same drawing with the steps. I've created a PDF and a JPEG, and I'll be inserting the JPEG, which has all the steps here that we've just gone through. The steps are over here. The visual steps are under here that y'all can use. And what the problem should look like when it's finished is right here. So all this will be loaded to the Google Classroom sheet immediately. All right. I think that this brings us to the end of this video now. I hope everyone was able to understand the topic of superior trochoids. I have also done a video on the inferior trochoids. So see that video and join us again for another presentation. As usual, I would encourage students to practice, and take things slowly. If you don't understand, stop the video, rewind the video, and go over it again until it makes sense. I am out.